Okay, thank you. Congratulations first. And I think his 5th visit to Taipei. 2 times for ACT meetings and 2 times for Kang's birthday symposium. And another one was for the FAOB council meeting, where when the Kang was away. But anyway, I'd like to thank the organizers for inviting me to this important occasion. And today, my talk will be on a proposal of a new stage after transcription termination. This was 35 years ago, I think, when I first joined Kang's lab at Stony Brook as a postdoc. That's the Kang and Felicia's lab was located in this building. I don't remember what occasion it was. And Felicia and Kang have a wonderful, spacious lab equipped with so many fancy machines. And this was the product of my research in Kang's lab, as a matter of fact. And this was accepted as we submitted, but we had to revise later to accommodate the new sequence for plasmid we used. But anyway, this was the table of that paper, and many years later, about 24 years later, I met a guy in a symposium in Santorini, Greece, and he's a Greek guy working in UK. Used to be a chemist, turned into physics, and he approached me and recognized my name, and then he told me that he used the data of this table all the time. So in fact, he posted this table on the wall of his desk. So he was a single molecule fluorescent spectroscopy guy, and he inspired me for the single molecule fluorescent studies, the subject that I'm talking about today. And because I found him working on a transcription, I naturally invited to our Asian conference on transcription, which I helped Grace to organize in the next year, in 2012, in Jeju Island, Korea. And this was the cultural program we had, one of the cultural programs we had in the ACT meeting. And this tradition actually started when Kang first organized the first ACT meeting, ACT meeting in Taipei. I think that was 28 years ago, right? And this was the first ACT meeting, and we had a special workshop arranged one day before the first ACT meeting, and you can see many of speakers today here. And Kang organized the first ACT meeting, and I organized the second ACT meeting this quarter. And then we went to, I think, Hualien, right? In 1990 for the ACT meeting. And this was the banquet before the ACT meeting, actually, after the conference workshop. And then I found this collection of signatures we made on the night of this fest. And you can see this signature list is studied with Felicia and Andy with Kang. And I was there, and Deepakar is there, and Akira Ishiyama from Japan. And I think it's Jerry Horwitz, right? And this only book, I guess, I remember. And the who should be there at the bottom. Okay, this was the speakers. Actually, this ACT in Kang organized another ACT meeting in 2005, which was the 9th. And I think when he stepped down from the president's of the NHLI, and we celebrate that, and along with his former associates. In fact, this ACT meeting was conceived when Ken and I gathered in Seoul for a FAOB meeting in 1989, when Felicia and Akira Ishiyama from Japan were also there. So we all got together, made a trip to Folk Village in suburb of Seoul. There we made a decision that Ken will organize the first one and I will organize the second one, and then the name will be Asian Conference on Transcription, which can be abbreviated as ACT-ACT. So this ACT meeting, it became a nice venue for a sort of regular reunion of Ken's postdocs, postdocs. This one was organized by Parker in 2008. And so today I will talk about what I have done after I left Ken's lab on the transcription study. So I changed the original title of my talk. I don't need this. But anyway, my major research topic is the discovery of disease-associated genes using genetic epidemiology. I touched on several diseases like this, but on a side, I still carry out the transcription research, and I will. So basically, we search the molecular interactions between DNA, RNA, and RNA polymerase during various stages of transcription. This is my version of the transcription process. And as you all know, all books describe a transcription is proceeding in 3 stages: initiation, elongation, and termination. But today, I'd like to announce that it needs to be extended. We have another stage after termination, because RNA polymerase is not dissociated from the terminating complex. And you get this binary complex after releasing of the RNA product. So I guess the future textbook should be revised according to this, if we ever succeed in publishing this data, which has not published yet. Okay? So I will outline the scheme we basically do. We start with a elongation complex, which is stalled at an elongation stage. And then we add nucleotides to proceed from the stalled elongation to go through the termination or read through the terminator, going downstream to the end. Okay? The DNA template is immobilized through biotin. And we use 2 dyes to label RNA and also DNA. So the RNA is labeled with green dye at the 5' end, and the red dye is located in various places, but usually at the end of the DNA template. So we have observed single molecule fluorescent changes, and one thing obviously we observed was the read-through complexes, which ignore the terminator signal. And this is where the RNA falls because of the terminator sequence, and show the fluorescent or resonance energy transfer. But it did not terminate and went through all the way to the end of DNA. That's where the protein reaches the dye at the end of the DNA, showing the enhancement of fluorescence signal. Okay, so this signal indicates that protein RNA polymerase reach the dye dispersed on the end of DNA. Okay? And RNA is released here because the size 3 dye labeled on 5' end disappeared, means the RNA is dissociated and released out from the field, from the complex. So about a third of the complex is indeed went through the termination, which you can see here, it drops completely. So the RNA disappeared because it was dissociated. And that, as you can see here, polymerase did not get off. It reached the dye at the DNA end, and showing this enhancement in fluorescent intensity. And that means RNA polymerase still remains on DNA, even if they all release out the RNA part. Okay? So that's why I say there's another stage of the transcription complex after termination, which is defined by release of RNA product. Okay. So then what would do, what RNA polymerase would do after releasing the RNA and reach the end? Now there are two ways. This polymerase can get off and get on to this DNA, or, as Nobu suggests, this RNA polymerase can slide down to reach the end of DNA. Now what we found, the one way, we have two evidence suggesting that this indeed slides down. The one is that if we make lower, if we make this distance lower, it takes longer, and you get less signal of the enhancement. And more direct evidence would be that we place a roadblock with a protein that binds there but doesn't do digestion, doesn't restriction enzyme, but it is proven already that this binding inhibits the sliding of RNA polymerase. So we use that, and when we place that, most of the signal was not observed. That means mostly these slides not. But when we have red dye up at the upstream end rather than downstream end, the RNA polymerase reached successfully to the upstream end because the roadblock blocks only the downstream slide. Okay? So what we can guess from this is the RNA polymerase can freely move around, slide around, upward or downward, but the E. coli blocks only the downward in these particular configurations. So we like to suggest the RNA polymerase slides down or upward after releasing RNA polymerase in transcription termination. Okay, and the next thing we did was we labeled RNA polymerase sigma subunit. The sigma subunit is presumed to be associated with RNA polymerase, and we found, the sigma factor used to be regarded to be dissociated just after promoter clearance at the transition from initiation to elongation stage. But recently, sigma was found to remain on complex at least only elongation stage. But now we found that sigma factor, most of them, remain on the RNA polymerase even after termination. Even after releasing RNA product. Now, at first it didn't make sense because structurally speaking, the sigma factor is supposed to block the RNA elongation. mean, RNA to get out of the polymerase from the active site. The sigma factor blocks that passage, so it is inhibited. So it has to be displaced. So our hypothesis is that it is relocated on the complex without being actually dissociated. I mean, that can explain both all the old and current data. So that's my hypothesis. But anyway, so sigma remains on the complex. It remains on the RNA polymerase even after releasing RNA product, and we have analyzed how much of them retain on the RNA polymerase. Okay. So when after releasing RNA product, RNA polymerase with sigma factor slides along the DNA template, then you can imagine easily that RNA polymerase can reach another promoter to initiate transcription. So we actually tested that whether it is possible. So one experiment we did was to add another transcription unit at the end of this template, including another promoter with a very long transcription unit. So in fact, we have found that this RNA polymerase can read, can initiate at another promoter here again to make this transcript. Now, when we had a roadblock in between, we didn't observe it. But without this roadblock, this transcript was produced. So we would like to suggest that this is a proof that RNA polymerase, after terminating, can slide along the DNA, upward or downward, and then find another promoter and can initiate transcription again there. Now, if it lacks sigma factor, that which we do not do, but it can associate it with sigma factor again. Okay? So we have some measurements over here, but anyway, the message is that RNA polymerase does stay on the RNA polymerase, the DNA template, and can reinitiate. Okay? So in conclusion, the transcription has to be extended to include another stage, which I call recycling stage, after termination. In analogy to the translation process, which is already now include fourth stage after translation termination. So I think our future textbook will describe the transcription in 4 stages, I hope. Okay, that's the end of my talk, and this particular research was a collaboration between my lab and physicists in Seoul National University. Thank you very much.